Alright, so today we have the infinite series of n cosine n pi over 2n. So I'm going to solve this using the alternating series test. But how am I coming to the conclusion to use this test? Because it doesn't even have negative 1 to the n, or negative 1 and minus 1, or anything to indicate that it's alternating series test. Why am I saying to do that? Well, if we take cosine of n pi and graph it, I apologize if the graph doesn't look that good. I'm not that good of an artiste. Negative 1. Okay, hopefully this goes well. Right. Wow, that's actually pretty good for me. Okay. See, at the low point is pi, and that would be 0, and that would be 2 pi. See, basically, no matter what value of n is, see, if n is 1, it'll be negative 1. If n is 0, it'll be 1. But no matter what the value is of n, it keeps on going from 1 to negative 1. Even if you had 1 million or 1 billion, it wouldn't get higher or lower than these values. So this is actually an alternating series test. And since n starts at 1, and 1 starts at here, it's a negative starting series. So, well, I'll just do it here. You could say it equals 1 to the n. So it's really alternating series test. So I'll rewrite it over here. N, but we didn't get rid of this n guy. N over 2 to the n. So the alternating series test, we have to make sure a couple conditions are met. So one of the conditions, we have to make sure that bn plus 1 is less than or equal to b of n. And this is our bn right here, this guy. So when I put bn plus 1, let's see if it's less than. So that'll be n plus 1 over 2 n plus 1. And we'll see if it's less than or equal to it. N over 2n. Now just by looking we could tell that it's less than, because the denominator is going to be greater here than here. So even if you, let's just enter a as 1, that'll be 2 over 2 to the 2, which is 4. So 2 to the 4th is equal to 1 to the half. If we put n to 2, that would be 3 over 8 compared to 2 over 4, which is less than, and so on and so forth. So we know this is true. Hooray! Now we have to do, this one could be a little tricky, the limit n approaches infinity of n over 2 to the power of n. How are we going to do that? Well, there's a couple ways to do it, but what I'm going to do L'Hopital's rule. I like saying that name, L'Hopital. 1 over 2n to the log of 2. Then you put infinity down here. Infinity times that be infinity, 1 over infinity, which would equal 0. And the two conditions are that the bn plus 1 has to be less than bn, which checks out. And condition 2 You know what? I should do that. Delete. So this is condition 1. And that has to be true. And condition true, not condition true, condition 2 has to be limit n approaches infinity of bn equals 0 and blah blah blah. That does equal 0. So both check out, which means that the condition is convergent by the alternating series test. So I'll just write it out. R, G, N, T. Okay.